All right, I have a couple examples of using the change of base formula, which is on page 311 in your book. So it's on page 311 if you want to check it out. I know that's a little bit hard to read. Okay, so when I have here log base 3 of 0.015, I can use the change of base formula. And basically there's three ways I can use it. I can use it to write this in any base I want. Base B stands for any base you want. I can use base 2, 3, 4, 5, 10. Most commonly, change of base formula is used using base 10 because then I can type it into my calculator, because you realize that when you use the log button on your calculator, it only works for base 10. So changing a log from one base to base 10 makes it a real quick way to solve a problem. You can also use the change of base formula to put it into the natural logarithm and also solve it. So we're going to use this form here, so I'm going to make it a log base 10 of 0.015 over log base 10, 3. Now often when logs are in base 10, we don't have to write the base 10, so you can just write this as log 0.015 over log 3. And your calculator will understand that that's in base 10. All right, how do you think I do this next one? Same sort of thing. So I'm going to put a log. Now, because I have 3/4, it's best to make sure you have that enclosed in parentheses, divided by log x. How about this one? Log x over log 1/4, or ln x over ln 1/4. So that happens to be pretty easy to use. What else you can do is, now that you have them simplified in terms of the change of base formula, you can graph these. Just type them right into your calculator using the y = button, and you'll see the nice curve. So I want you to try that too, and there's some samples in the book that you can look at. All right, I have a few examples using the properties of logarithms. And again, these properties are listed in your book. I think they're on page 313 or 312. All right, first thing I'm going to do is write this division as two separate logarithms. So I'm going to write this as, well, it's a natural log, so ln xy minus ln z. I use that property there. Now, I'm going to write this as two separate logarithms, just like this property. So final answer, ln x plus ln y minus ln z. All right, here's another one. First, I'm going to write this as ln t to the 1/3. Hopefully you remember that the exponent for this is 1/3. And then I'm going to move the 1/3 to the front. That's the third rule here. So this is 1/3 ln t. And now, if you knew what value ln t was, you could type this right into your calculator. Or you could type it into your calculator and get a graph. Oh boy, look at this baby. All right, first let's use the division rule. So I'm going to do ln x to the 4th root y minus ln z to the 5th. That 5 can be written in front. This I need to use the separation rule and the exponent rule all at once. So I'm going to separate these two and move that in front. So I'm going to do, well, let's do it in two steps. So I'm going to have ln x to the 4th plus ln root y minus, I'm going to separate this one to 5 ln z. I still have a little more to do here, because this could be y to the 1/2. I can write the 1/2 out front. This 4 I can write out front. So final answer here would be 4 ln x plus 1/2 ln 5 ln z. And can you see that last part? Yeah. So there you go.